Hi, I'm Ryan Carniato, the creator of the JavaScript framework Solid.js. As always, I'm excited to be talking at VComp. It's one of my favorite talks of the year because it has a way of bringing all the communities together, which isn't unlike what I'm talking to you about today, which is our journey to bring the client and the server together. This is no easy task, as I'm sure you're all aware, and we've been trying to do this a number of ways the past several years. This has been a journey. It would be easy to mistake this as a return to the past, relearning the lessons from like PHP or Rails. And while there's a little bit of that, I wouldn't say that's been the defining characteristic. When JavaScript made its mass exodus from the server languages to establish its own identity, a lot of what doesn't work was discovered. There's a reason almost no JavaScript framework identifies as MVC anymore, etc. We return to the server, this time with purpose. In no way this is a new trend, but it's one that has taken a long time to mature. The cost of ambition, really. The scope of what we are all trying to accomplish has moved beyond what a simple renderer can accomplish. And since we aren't just satisfied with the past, it's insufficient to view the client and the server as separate things or repeat, other mistakes of the past. We needed to recognize the solution isn't one of these things, but all of these things. That's a lot when you consider the abstractions built on top of this as well. But building the abstractions isn't so much the problem, as much as understanding the boundaries underneath can shift with each of these new abstractions. Still, the way out is to consolidate the base primitives. Vite continues to be a source of that normalization. If not Vite itself, libraries very close to it in the ecosystem. Things like Nitro, which powers Nuxt, Analog, Solid's meta framework Solid Start, and the upcoming TanStack Start. And Vinci, which powers the latter two. It's another layer to handle the abstractions like server functions or server components and file system routing in a generic way. And with Vite 6's upcoming environment API, what might be the biggest reason for us creating Vinci in the first place is getting baked right into the core of Vite. So there's this cycle here. We needed these features before they ended up in Vite, but in the end, we reached a place of consolidation. And trusting in that means that a whole bunch of things I don't need to worry about anymore. Which brings us to the present. Yeah. Solid Start, Solid's meta framework, built on Vite, Vinci, and Nitro, has reached 1.0 as of May. I'm very happy about this, as it's a culmination of work of hundreds of developers, and honestly, most of the last 3 years of my life. It wasn't easy to get here, but I'm happy with the results and that you've all been with us through this journey. First, when we leveraged Vite to introduce server functions to the world, that is the ability to create compiled typed RPC calls from annotated functions. This would power Solid's data fetching and action APIs, as well as become the means for server functions in Quick and server actions in React. This slide was from that original talk a couple of years ago. We've changed the syntax over time. Now it's use server, but it's the exact same concept. And then again, when last year we presented the first routerless JavaScript framework, when we recognized that the router carried the opinions that could be isolated, this powered our client-only SPA mode or single page app mode and opened up the door to other tools being used first party inside Solid Start. It opened the door to bring your own file system router conventions as well, not to mention a baseline bundle size of just 4.7 kilobytes minified and gzipped. Unheard of, really, from a fully hydrating SSR JavaScript framework. Everything a la carte. But I want to stress that we got here sort of by necessity, not completely by choice. We set goals as to not alienate our growing ecosystem. Very important. And those constraints actually led to this innovation. But, that's been the last couple of years. You might be asking, what have we been up to this year? Well, it started with significant funding from the Chrome team. We hired on another full-time developer, Alexis, to explore improving the ways we build on the web. Our initial goal was to bring our movie app demo to the mainstream. It was basically our take on server components. That solved a lot of the problems that other server component solutions had not. Removing duplicated serialization, keeping the code size incredibly small, while maintaining that client-side routing. The demo had done so effectively, handling navigation and actions seamlessly. It was a fraction the size of other frameworks, including normal solid start, and outperformed them all. However, it was limited and had some really significant flaws. First of all, it didn't handle persistent state all that well, which could easily lead to hydration errors. It was pretty brittle, to say the least. And secondly, it wasn't designed to handle streaming async after the initial page render. Yes, it could handle async data, but it all came in as a single chunk instead of streaming it in. So we kind of started our exploration focusing on that second objective. Yep, it all leads to serialization. We needed a data format to handle async and nested async. We needed the ability to send data over the wire with the promise of resolving more data afterwards. We needed to be able to send HTML and have more HTML stream in the same way after we do that initial render. And well, we identified a few other problems too. The main one was that in an SPA, data serialization is pretty straightforward. It more or less exists outside your app and ends up being appended as some large JSON blob. You've probably seen this next data blob before. It's pretty much omnipresent in our current server rendered single page app world. Remix data, Nux data, Svelte data, solid start data, so on. But with islands or client components, whatever you choose to call them, we need to serialize the props for each island. This has a benefit that not all the data needs to come to the browser. But because there are more entry points, and often, even if not all the data makes it to the browser, some nested part of it does, it might be shared across multiple islands. The combinatorics of how this is handled, if naive, could actually increase serialization overhead, sending the same data multiple times. And of course, this doesn't bring in async. What if certain islands are only available after other async data loads? We need to keep these serialization references across each flush. So I want to introduce you to Cerevel. This is Alexis's creation, the project that now powers all of Solid Start's serialization, right? And fortunately, Alexis made a little playground so that we can play with this. On the base level, I'm just going to return an object so you can see it, and you can just click serialize. And you can pretend like this side is the server and this side is the client as it gets the data. So we can serialize something, send it across, and we see that we have this kind of self-referencing object for deduplication. We get our greeting across. And what's kind of cool about this is I can take this object and just kind of show you, we could, return an array and have this object show up 3 times in it. Sorry. And what you're going to see is we send back the array, and the first one gets assigned to a reference here. And then we use the same reference for the second two. I mean, this isn't too tricky to visualize how this scales, but this is definitely very cool. We're able to serialize all sort of data shapes and essentially be able to have them spit out the other side. And this includes async. I actually had a little fun here playing around in this playground. What if I made a countdown, like recursive call? So essentially this is creates a promise with a timeout that until the number gets down to 0, it resolves another object, which gives you the current number, and then countdowns again. So I'm just putting promises and promises and promises and promises, and just start by returning the first countdown. So we're going to count down from 5. And when I serialize this, again, this is the server. You can pretend this is the client. What you're going to see is initially it sends commencing countdown, and then it'll send 5, and then 4, 3, 2, 1. Every second, blast off. It actually handles sending it each in pieces as it comes down automatically. Obviously, I could do something like change the delay, change the number. Let's try this again. You can watch it come down. 5, 3, C, and so on. So we can construct interesting async patterns of data, and as long as they get passed out, they can be serialized. Of course, doing promises like this is a little bit chunky. Cerevel supports async iterables, so we can make a promise and run it through an async generator function. And here this is the base example on their page. They have 1, 2, 3, uno, dos, tres, things as all iterators passing the object. And if we serialize, you're going to see the next functions being called on these iterables as the data comes in. And this is pretty powerful because async iterators and iterables are basically stream protocols. This is how you can do observables, readable streams. It just kind of built in that, but simply by having an async function or generator function, you can pass data as a stream from client to server. So I hope you're starting seeing the power of serialization here. So we got here and we continued our exploration into solving server components in a performant way, but we kept hitting more complexity. We found that in serializing props, we brought back the double data problem again. That is, everything currently being rendered gets serialized twice. Now in the HTML and as a prop. There are tricks to reverse template props out of rendered HTML, but even deciding what to serialize based on what is rendered initially is actually hard thanks to async. You could be needing to send part of a client island without even knowing if that prop will ever be used. Do you serialize it or don't you? Yeah, think about that one for a minute. Even after we came up with some clever solutions, bridging the data fetching story and mutation between server and client was still a mess. Our server components on a given page all rendered together, meaning every re-render, every mutation meant refetching all the data on that page. Suddenly, our baseline examples required blob storage and caches, which ends up making it specific to certain infrastructure. You know, if I want to deploy this on Cloudflare, do I use their KV? Or if I go to Netlify, use their blob storage or Vercel. And this was kind of necessary with this architecture for it to be performant. We didn't have any of these concerns with our SSR single page app. All through this, I found myself doing more and more, simply just taking server functions with Laravel to represent my data. So I thought, what if this was enough? If we weren't going to solve double data in a convenient way, if our framework is small enough to orchestrate loading assets on the client as needed, if we've already solved data loading waterfalls, if we had a means to run code only on the server, whether called there or in the client, what's the biggest issue left we face that would make something like server components valuable? Well, I only really came up with one thing, and that was single flight mutations. Wait, not this, this. Now, it might seem obvious that the first side, the multi-flight here, is a bunch of extra work. Right? We send an action down, get an acknowledgement, then validate or redirect, and then fetch the data. But client apps have kind of gone this way the last few years. No one wants to manually deal with cache management at application level. Not to mention, when the client is responsible for routing, it knows what data it needs for the next page. Sometimes we don't revalidate, we redirect. Sometimes we do a bit of both. So sure, it would be easy for some mutation to return a piece of data back when you update it, but applying that change and all downstream changes of a mutation can involve a lot of wiring. So we don't. We just rely on TanStack query or framework loaders, which, let's face it, make it a breeze to implement consistent APIs. But the old form post was single flight because it re-rendered the whole page, right? You posted your form and then got the HTML for the next page back. Server components are single flight for a similar reason. Can we keep our powerful granular APIs and do single flight? Yeah, of course we can. We have incredible knowledge when combined key-based revalidation with nested routing and hoisted data fetching. You could picture a simple social media site where you have a users page and maybe a feeds page. And under the users page, there might be posts and settings. Each of these route section knows what data it needs. So if we were on if we had taken, users settings, like Ryan Solid settings, and navigated back to my post page, we could tell from this graph that we only need to fetch the new data for posts, and the rest of the data on the page is fine. And more than that, we can perform actions which can cause redirects and invalidate certain data on the page. For example, if a settings page updated the user's name, and we realized we had to update the user profile. Well, we could just, via key, say, hey, this needs to be refetched. So now it can say invalidate this and redirect back to posts on save. And it will know to fetch both pieces of data. It occurred to me while working on this problem that we had all that information at the time of action on the server before we even responded to the client. So if we know that and we have a super serializer, we could simply respond right away to tell the client to redirect while streaming back the promise of the data that we would otherwise need to fetch. We could literally, because it's separated, because it's hoisted, and because we know what route we're going to, we could start fetching that data on the server in the same request and have it come in all at the same time without changing the model. No need for that second request. Your DX would stay the same, yet doubling the response of every single mutation you do on the page. So we used that and made our own Trello board demo with this technology. I think a lot of you have seen this demo before. You can go in, you can add a card. Let's add third card. You can move cards around. Sorry, grab the thing. It's a fun little demo. And if we look at the network, what you're going to notice, first of all, is that when we do this install start and move stuff around, it's only one request. We don't do two. And the reason we can do that, again, is we have Cerevel here. This should look a little familiar, serializing the data we need for the next fetch. So everything can be single flight, right? And if I go in here and say, make the network really slow, now you can visually see here how long it's taking to resolve. There it goes. And obviously being single flight, that's already twice as fast as if we were doing two. But the optimistic updates here handle this pretty smoothly while we're waiting. So smoothly that we should be able to drag stuff around, drag it under, and have multiple things in flight if I can move fast enough, as you can see, and not have this concern with losing state of our app. Now, this is pretty powerful and pretty happy with the results of this demo and the work done by the community members who actually built this. But it's just an example of how these things layer together quite nicely. What's really cool about this example, which if you ever get a chance to check out the source code here in this repo, is that we basically can use our combination of optimistic updates and then have the information here to apply each update individually. Most libraries, when they do this, like with the VDOM you have to take the existing board and every time you add a new mutation, merge it all together, diff it all. With the fine-grained approach we take here, what will happen is each mutation is applied independently. We don't have to merge them every time, only as they get added. So if I go in and rename this card, maybe we want to make it second card, we only actually apply the mutation of the specific text in the client while we're doing it. And then when the server comes back with the fresh data, and we do have to do that diff, well, nothing's changed. So in a sense, no components rerun at all in this process in what I just did. So combining the fastest approach in terms of single fetch with the fastest way to doing the least work in the browser. I'm very impressed with the work that the community did here. So what am I saying? I'm happy with where things are, but they're still evolving. Most of the content of this talk is technology we released actually 8 months ago, and we're already kind of on the next thing. But it's amazing to live in a time where we can so rapidly prototype out these ideas and explore different approaches. And having the tools available to accelerate this is what makes it all possible. That last demo has had a huge influence on how I view reactivity and the approaches we're taking Solid 2.0. So I'm very thankful to have this platform to build on. Very thankful to Vite and this community. If you like what you heard today, you can find all the resources off solidjs.com. Find me on Twitter at Ryan Carniato. And if you really like nerding out, on JavaScript frameworks. I stream weekly on YouTube and Twitch. Thank you.